Well, now we come towards the analog communication and its disadvantages. So, analog communication, I have already explained in the earlier concept. In the analog communication, we use the sinusoidal current. So, analog communication makes use of analog electronic circuit, and analog signal is such a way that the output voltage varies continuously in accordance with the input voltage. So input voltage is also sinusoidal and output voltage is also sinusoidal. Now the next is, for example, analog communication is carried out in telegraphy, telex, TV network, etc. These are examples of the analog communication system. The analog operation is less reliable due to its many valued outputs. So outputs are too many, so that's why this is less reliable. Sometimes this communication fails also. Now next is about the digital communication, enumerating some of its advantages. So in this question, we have to discuss what is the digital communication, and we have to explain certain advantages, that is the uses. So in the digital communication, we find that the communication is convenient. Digital communication makes use of electronic circuit that can handle only digital signals. Modern communication systems like fax, email, etc. are purely based on the digital electronic circuits because of the following advantages. So there are many advantages, like number one is, as compared to many valued analog operation, the two-valued digital operation is more reliable. So in analog operation, output signals are too many. But in the two-valued digital operation, it is more reliable because here all the signals are easily identified as low and high. As the information to be transmitted is already in pulse form, so its transmission needs simple technique. Pulse means that where the wavelengths are very short, the frequency is very high. And third thing is, a large number of digital signals can be sent through a single channel. So we don't require a band of the channel, only single channel can carry out this type of communication. So large number of digital signals can be sent through a single channel only. And our next question is related to bandwidth of the signal. Bandwidth means many frequencies constitute a bandwidth. So let us see what is the main concept regarding the bandwidth of the signal and its importance. The bandwidth of the signals, that is the range over which the frequencies in an information signal vary, is called bandwidth. So many frequencies are there in the bandwidth. It is equal to the difference between the highest and the lowest frequencies present in the signal. So the collection of highest and lowest frequencies in the bandwidth in the signals, that is called bandwidth. The type of communication channel needed for a given signal depends on the bandwidth of the information signal. Now we have certain examples here, like speech signals. They contain frequencies between 300 Hertz and 3100 Hertz, 3100 Hertz. Normally, the sound signals, they are called audio signals, and their frequencies vary from 20 Hertz to about 20,000 Hertz. However, the frequencies between 300 and 3100 Hertz, they are supposed to be the proper frequencies for the communication. Such signals require a bandwidth of 2800 Hertz, that is 3100 Hertz to about 300 Hertz. So the bandwidth will be, that is the range of frequencies which we can communicate. So for telephonic transmission, we can have a bandwidth that is having 3100 Hertz to about 300 Hertz. Now, audio signals have frequencies between 20 and 20,000 Hertz. Now, we can say 20 kilohertz means 20,000 hertz. So transmission of good music requires a bandwidth of about 20 kilohertz. So if the bandwidth is 20,000 hertz, it means that it will be the transmission of a good music program. Video signals required for transmission of the picture have a bandwidth of about 4.2 megahertz. Wherever we use the term megahertz, we are referring to 4.2 into 10 to the power 6 hertz. So video signals, when we are receiving, they are 4.2 megahertz. Now, if we wanted to find their wavelength, the formula is quite simple. That is, velocity of these signals is nearly 3 into 10 to the power 8 meters per second. Now we come to the TV signal, which contains both voice as well as picture. So it is allocated a bandwidth of nearly 6 megahertz for transmission. So if we require, that is both picture as well as the voice, then 6 megahertz, that will be the bandwidth. So next is regarding the rectangular wave we generated from the superposition of sinusoidal waves. So we have to go through the mechanism in which rectangular waves will be generated from the superposition of the sinusoidal waves. So sinusoidal waves will be in the form of sine graph. So they will superimpose and then different patterns of the wave will be generated. So first of all, we come towards the figure, and in this figure, what exactly we are viewing, the A part is indicating the square wave. So it means that when many frequencies superimpose, there are certain points where square waves are generated and they are called the digital signals. Similarly, B part is written fundamental frequencies, that is the original frequencies. Fundamental frequencies, also known as, that is first harmonic. The term has been taken from the propagation of sound. And now we come towards the C pattern of waves, that is fundamental frequency. And second harmonic is 2F naught. Then fundamental frequency, that is second harmonic plus the third harmonic, 3F naught. So what exactly we are viewing in the pattern, that A is a square wave, that is digital signal. B is a fundamental frequency, that is the first harmonic, and C part is indicating fundamental frequency plus the second harmonic, hence it is double the fundamental frequency. And similarly, fundamental frequency is added to second harmonic, that is 2F naught, it is added to third harmonic, that is 3F naught. Like this, the frequencies vary. On x-axis, we take into consideration the time instant, and on the y-axis, we take that is voltage or current in the sinusoidal form. So the pattern is shown when sinusoidal values or different sinusoidal values superimpose. Then these types of A, B, C, and D waves are generated. So now we come to the main context, approximation of the rectangular wave in terms of fundamental sine wave and its harmonics. Now it is known that sinusoidal wave is an analog signal, while a square or a rectangular wave is called a digital signal, as shown in the figure. A rectangular wave can be generated by superposition of sinusoidal waves of frequencies f0 to f0, 3 times the fundamental, or up to n times f0, where n is an integer extending to infinity. It should be taken as 1, 2, 3, 4, and so on. That is all the multiples of natural numbers. Now, to reproduce the rectangular wave shape more exactly, one needs to superimpose all the frequencies. So when the frequencies f0, 2f0, 3f0, and 4f0 superimpose, then we get a digital wave. This implies an infinite bandwidth. Practically, the contribution from the higher harmonics are negligible, which limits the bandwidth. So that is called the limit of the bandwidth. Beyond that, it cannot accommodate any other frequency. Now, consequently, the received wave is distorted version of the transmitted wave. However, if the bandwidth is large enough to contain a few harmonics, the information is not lost and the rectangular signal is exactly reproduced. Rectangular signal means digital signal. This is because the higher the harmonics, the less is the contributing to waveform. So it means that if the frequency or the harmonics will increase, there will be less contribution to the waveform. Means there will be digital form, which will just follow each other.